Morning. So today we're going to be looking at the differentiation of expressions involving e to the x. So what I want to do is I want to write a simple expression of y equals e with some coefficient k x. Okay, so e being raised to this power kx. Now, by the rule, when we have a look at dy dx, what we get is k comes out, e to the kx. So you must remember that this is a fundamental rule when you're dealing with functions of this nature. Now, what I also want to do before we get into a few examples is I want to have a look at what happens when we deal with a composite function of this nature. So I'm going to talk about hx equaling e, and then we can have a function fx. So e raised to some other function. This gives it a nature, because of this fx, that it is going to be a composite function. Now, if we remember with our chain rule, what we might do is we might say y equals e to the fx, and we'll say let u equal fx. Therefore, if I write du dx, that's simply going to be f dash x. Different notation, but they mean the same thing. And y here equals e to the u. And if I look at dy du, then that should give me e to the u. The reason for this is because there's a 1 there, and that 1 just gets transferred here. So we don't need to show these ones, but that's what it gives. And I'll just take that off, change the colour. Dy du should be expressed as e to the fx if I substitute u for, or fx for u. Therefore, h dash x, which is also known as dy dx, equals du dx times dy du, which is our chain rule, is going to equal f dash x, which I've taken from here, times e fx, which I've taken from there as well. Okay, and this is a rule that you want to remember when you're dealing with powers that have been raised to e. Now, I'll just put in here, remember e equals 2.7, 1, whatever the digits are. It's a non-terminating decimal, but it's a value. You must appreciate that it's a number. It's an actual value. It's an irrational value, given that, but it's not some algebraic term that we deal with. It's an actual value that we need to be able to work with. So when we have some questions here, and what I'm going to highlight is in our first example, I'm just going to look at question 3a. And it says in 3a, find the gradient to the curve of y equals x squared plus 4x at the point 0 and 1. So what I'm going to do is I'm going to write my original equation plus 4x. Now, I may also want to rewrite this original equation just so I can bring a coefficient out the front. Now, that coefficient is a half. It comes out the front. It sort of makes my computation of the derivative function a lot easier. So I'm going to deal with this in parts. So with the first part, I have e to the half x. So I'm going to derive that. So that half comes out the front. I still have a half x plus 4. If I just deal with this section, the derivative of 4x is just given as 4. So I could rewrite dy dx as equaling e x on 2 all over 2 plus 4. And when we start having a look at this question, and we're dealing with the coordinate 0, 1, in this first instance where they're just looking for the gradient of the tangent, all I've got to worry about is when x equals 0, dy dx will equal e 0 on 2 plus 4. Now if I know my values, e to the 0 on 2 is e to the 0, that's just 1 on 2 plus 4, which will give me 9 on 2. And if we check it, it is correct. Okay. Going down to question 4 and looking at B, we're going to do a similar thing, but here we're going to have to notice that this expression involves a composite function. And the composite function is this section of the function that we need to be aware of. So when I evaluate dy dx, I'm going to first find what the derivative of this function is going to be, 2x plus 3. And then this is going to be e raised to the power of x squared plus 3x. That's going back to this rule that we had a look at and did a proof of. And then we're going to derive this section of the expression, which is just 2. And then we're going to do the same thing as we did in our last example. We're going to ask ourselves when x equals 1, because that's what this is showing. And we're going to be saying dy dx equals 2 plus 3 e 1 squared plus 3 plus 2. And we're going to have 5 e to the 4 plus 2. And if we check the answer, this is also correct.